Hey guys, welcome to my new McDonald's video. Back at you again is Robin Lee, and today we're featuring the McDonald's CEO, Lucas Lindo. As with tradition, we were sponsored by Raid Shadow Legends. Collect over 100 plus heroes to your collection, including the ones from your favorite animes like Fortnite, Core in the House, League of Legos, and Sword Art Online.
What's the problem? We need the big M. But also, I've always had a childhood wonder of how much it would cost to put a McDonald's sign in front of my house. Why is this a problem? We need to make a sign of the logo. Without it, we are not McDonald's. We cannot sell McSalad to health conscious people. We don't know how much the sign costs. We can't calculate the cost without finding the area. Watermelon. How to solve the problem. Here's the hardest part. It's actually solving the problem. But thanks to me being CEO, I already did the problem. Look up the dimensions of an average McDonald's sign. Realize that there's virtually no information about it. Make a parabolic function based on the McDonald's sign with made up dimensions. Realize that the parabolic functions don't fit the curve. Use big brain to find out the exponential functions fit the curve. Find volume of m. Find cost of the m. So basically, you match some exponential equations to outline the m of the McDonald's logo with trial and error. And here we have the equations by themselves. We simplified the process by having similar x-intercepts for both the top and the bottom lines in order to make the areas for each half easier to find. First, we need to find the area of the left half of them, which will use these equations. We find this area by taking the integrals of the functions and subtracting the larger integral with the smaller integral. For the limits of the integration, we use 0 to 2.8 for the larger integral. For the smaller integral, we used 1.173 to 2.5 because 1.7173 is a 0 for the function.
For the other side of the m, we do the same thing. We first need to find the integrals of the curves. You might be asking, hey, Robino, if the middle part of the m doesn't hit 0, would it be an overestimation of the true integral? Good question. I just subtracted 0.6 in order to make the functions hit 0 at the base of the m. With that problem out of the way, we use the same steps as we used before for the left part of the m. We subtract the larger integral by the smaller integral. For the limits of integration, we do the same thing as we did for the left half. With the new functions, the larger integral is 2.8 to 2.25. The smaller integral is 2.8 to 4.392 because at 4.392 is where the 0 is at for the function. Yeah. Now we have the area of both sides of the half m. So we can find the area of half of the m. So we just add the areas together. To make the m complete, we just multiply the entire area by 2. And ta-da! Look, it's the total area of m.
Now, in order to find the cost of producing the m, we need to find out the cost of each cubic meter. So we find the cost of a gram of gold and divide it by its density to find out the cost of gold per cubic meter. Then we calculate the volume of the m by multiplying the area by the width. With the volume, we can multiply that with the cost of gold per cubic meter to find the total cost of our m, which is about $120,641.81.
And here's a link to our work for you nerds. And here's a sad tire.